this person, okay, that created a setup. Now you need to look at the setup. Sometimes when they give you this kind of picture, you have to look at it to understand it. Of course, they will write it in words as well. Some of you don't even want to read. If you don't read, good luck to you, okay? You won't even know how this works, all right? So you need to read water from the tank. So it's over here, it's up here, the water tank. So water from the tank drips into this little cup. This cup is fixed onto a steel rod, so it's stuck there, okay? Then you continue reading. When the cup is filled with water, so the moment it fills with water, it will start to move down. Obviously, when the cup moves down, the other side of the rod will go up, right? Which is why they say that this causes the other rod, okay, or the other end of the rod to basically move up and touch the other steel rod, which is here. Can you all see? So this thing will go up and touch the other steel rod. Easy, right? So then this will cause the buzzer to go off. Now, if I ask you a very simple question, how come when the two rods touch each other, the buzzer will go off?
Because of magnetic materials.
Because it creates a closed circuit.
Because you see a closed circuit. Where's the closed circuit? I show you all. The closed circuit will be, imagine this moves up, so it'll touch, right? There'll be a closed circuit right here. Can see? These are your batteries. Okay, let me erase so you all can see now. Okay, there'll be a closed circuit. That's why the buzzer will ting, it'll ring. Okay, are you all clear on this? Now let's move on, okay? Where's my arrow? Okay, here. Fill in the boxes below to show the energy conversion taking place as water is dripping. Now, water is dripping into the cup. So look at this, water at point A. Where is point A? Before you all tell me GPE, look at where the point A is pointing at. It is not pointing at the water tank, okay? It's pointing at the water what?
Kinetic energy.
Yeah, so it's pointing at the water droplets and obviously it's moving, which is when this water is dripping at point A, what is the steel rod with a cup? What kind of energy will the steel rod with a cup possess? In order for you to answer this, you need to know how this setup works, right? Because when the water drips onto the cup, what will happen to the cup? It will move down, which is why what kind of energy will be possessed in the steel rod with a cup?
Kinetic.
Yeah. So yeah, when this thing moves down, right, this steel rod is going to go up and touch the other steel rod. So the moment it touches, it's the same thing when the ball lands on the sand. There is an impact, it will have heat and sound energy. Which is why here is actually heat plus sound energy. Okay, because when the rocks touch each other, heat and sound energy first, then it's converted to your electrical energy, then it's converted to your sound energy in the buzzer. All right, now comes part B. Okay, explain how the cup is emptied and refilled with water. There's two things you need to explain. One is, how will the cup be emptied? Obviously, emptied means how come the water will be emptied, right? How come the cup will empty the water, basically? And secondly is, how come it can refill the water? So I don't know why they ask this question. There's no energy involved, okay? It's a very simple question. You just need to tell me from this setup, how does the cup get emptied? Heavy or light?
When the cup, all the water from the cup is removed, it will go up, and the water tank will fill it again.
Right, it will become light and go up. You're right. Then go up, then can the water drip back into the cup, right, from the water tank. Okay, so the moment the cup moves up, that's when the water can drip back into the cup again from the water tank. What will happen if he changed all the wooden supports to steel supports? First, you must ask yourself, is where in the world are the wooden, where's a wooden support?
There.
Thanks for telling me, is there? I have to go figure myself. So I will align it, okay? So basically the steel rod one is here. This is also a wooden support. This is also the wooden support. This is also the wooden support. Okay. Whatever it is, they change the whole wooden support to steel supports. Look at this. Okay, I traced the electricity for you all to see. If I change these wooden rods to all steel rods, now I put it in blue for you all to see. You see, and then there's water here, you know. Water. I use the orange color and show you. Look at this very clearly. If this whole thing is steel and there's batteries here, your electricity will flow like that. Can you see a closed circuit right here? Yeah. And all the more like what Tavis said, right? The steel support and the water, these are all conductors of electricity. Your buzzer is going to keep on ringing. That's why the supports are wooden, because wooden is an insulator of electricity. Now, when you look at part C, you know that this has nothing to do with energy explanation, okay? This you must explain in terms of your electricity. All of you, when you're explaining electricity, there are 4 steps, okay? I'm going to write the steps now, okay? So again, energy got 2 steps, this one 4 steps, okay? Electricity, there's always 4 steps, you must remember. Step 1, I call it the situation. I will show you what I mean, okay? Just write the steps with me first. Step 2, you must always tell me, is it an open or closed circuit? Oh no. Okay, I need to quickly go get my charger soon. Okay, step 3 is electricity flow. Step 4 is you telling me the outcome. Now, this, when I revise the topic on electricity, I will use these 4 steps to explain. Okay?
Can I answer this one?
Okay, wait. Okay, let's hear Shok answer the situation. What is the situation here when I change wooden supports to steel supports?
Water would be, electricity would be conducted.
No.
Steel is a conductor of electricity.
Yes, you must tell me steel is a conductor of electricity. Okay, this is what you have to do. Can you all now write the 4 steps and write the answer in green? Okay.